Hello everyone, this is just a quick introduction to something that's going to be pretty new for you guys this year, trigonometry. It's not going to solve all your problems, but if you can watch this and come to class prepared, then we've got half a chance of learning this fairly well. Start off with trigonometry. It's really no more than ratio, and you'll actually hear your teachers refer to them as the trig ratios. So if we can go back to some of your year 8 work here, here's a little example that's got nothing to do with trigonometry but is about ratio. You've got a cake mixture, and for every 500 grams of flour, say that clearer, it's 500 grams of flour, you need 100 grams of sugar. So the ratio therefore is 500 to 1, or 500 to 100. Let's make it simply 5 to 1. Well, how do we use that ratio? We're going to make a cake that needs 75 grams of sugar. You'll need 5 times as much flour, because that's the ratio, so you'll need 375 grams of flour. Now that doesn't help you a great deal with trigonometry, but it just gives you a little bit of understanding about how we work with ratio. Because we do exactly the same thing with right-angled triangles. Now you guys should just be at the end or still be doing some work on Pythagoras. We've done a lot of work on that. Right-angled triangles are the same with trigonometry. It's about using some ratio to find sides or angles in right-angled triangles. Here's a quick example of ratio in triangles. We haven't even got to trig yet. This is just still on ratio. Right here is a right-angled triangle and a bigger one there. They are what we call similar triangles. They are almost the same except one's bigger. I haven't marked angles in there, but what you'd find is the angles are the same. This is a pretty simple ratio from this one here to this side there, and then from this side there to this side there. Hopefully by now you've worked out that the ratio is 3 to 1, or 3 times bigger. 3 times 3 is 9. 3 times 4 is 12, so clearly 3 times 5 is 15, and so this side here would be 15 meters long. Let's have a look at this one. This time we've got an angle in here. Now this tells us that these two triangles are similar, because if you've got a right angle here and a right angle there, 45 degrees there, 45 degrees there, well, this angle also has to be 45, and so there. So they're similar. They're not the same. One is much bigger than the other, but they are what we call similar triangles. And again, it uses simple ratio. This is 3, and this is 12. You should be able to see, therefore, that that is 4 times as big. So this over here should be 4 times as big, so that would be 20 meters. This is what I'm about to show you now is the first little start of trigonometry. You have to learn this and know this. I'm not kidding. Right up to year 12, the most common mistake we have with people and students with trigonometry is they mix up the 3 sides of the triangle. We've given them all names. You've known for a couple of years now that the long diagonal side, the one opposite the right angle, is the hypotenuse. This symbol here you've probably never seen before. It's what's called theta. Now that's no big deal. All it is it's a symbol that represents the unknown angle. We don't know what that angle is. I'm just marking the angle there because the angle is important to what we want to learn. So there's our angle. We mark it with the theta sign. This side over here is called the opposite. Now it's not hard to remember. It is opposite the angle. Now that's why I've marked the angle with theta, because it becomes important to the opposite. If someone lives opposite you, they live across the road from you. So that side is called the opposite. It's got nothing to do with the left, the right, the top or the bottom. It's all to do with the angle. The opposite side is opposite the angle. If someone lives next door to you, then just across from you, we say that they are adjacent to you. So this side, which is just right next to the angle and helps form the angle, is called the adjacent. A really common mistake is people mixing up opposite and adjacent all the time. If you do that, you'll use the wrong ratio and you've really mucked things up badly. No one should muck up the hypotenuse. I think you know what that is, and it's a hypotenuse, not hippopotamus, alright? It's not a big fat animal, it's a side of a triangle. But mixing up adjacent and opposite is a really common problem we see all the time. Opposite is opposite the angle. Now let's have a look at this as an example. I usually start with this one. I think your teachers will probably try and teach this to you pretty early on as well. We start with sine of 30 degrees. Now the reason we start with that one is it's a really simple ratio. The sine of 30 degrees is actually the ratio of 0.5. So the sine of 30 is 0.5. In class I'll get you to type that into your calculator. You'll come up with the answer a half or 0.5. What that actually means is that it's a simple ratio. This side here, the opposite, will be exactly half of the hypotenuse. Not for every single time you do something, just if the angle is 30 degrees. If the angle is 35 degrees, it is a completely different ratio. But just in this instance, this angle here, this side here, sorry, will always be half the size of the hypotenuse if the angle is 30 degrees. Let's see. So therefore that should be 18 meters, because this should be half of that. That's a ratio. Sine of 30 is the ratio of 0.5, which means the opposite is half the size of the hypotenuse. Let's look at something a little bit more involved. This one, as we can see, we have an angle of 40 degrees. We have an opposite side of x. We want to find that out, and we have a hypotenuse of 6.5. This is the adjacent over here. That's not concerning us at the moment. This is a sine problem, and I just want to find what the opposite is using the ratios that are between these two sides, the hypotenuse and the opposite. Let's have a look at something first of all. If you type sine 40 into your calculator, you'll get 0.643. You might even get a few more numbers than that, depending on what it's rounded to. That means that the ratio between the opposite side and the hypotenuse is that the opposite is 0.643 the size of the hypotenuse. Now, nothing as easy as before when it was just half the size, and this is why we need our calculators. What the hell is 0.643 the size of 6.5? That's too hard. That's why we use our calculator. Let's have a look at what we do. We always start with a formula. Do not freak out about how I know it's a sine problem or how I know that it's opposite divided by hypotenuse. You'll be taught that in school. For now, we just want to get a basic understanding of what trigonometry is. It's the ratio, which is the relationship between the different sides according to the given angle that you've got. In this instance, this is our ratio. Let's use it to find this side. Don't worry about this. This will be explained later on. Just like any measurement, we've got formula and beautifully neatly set out, equals under equals. In your recent linear equations unit, we taught you how to transpose formula. The formula was sine of the angle is opposite divided by hypotenuse. I've changed it to opposite equals hypotenuse times the sine of the angle. That's because I want the opposite here, because that's what I'm trying to find out, the opposite. Now, like any good measurement problem, swap the letters for the numbers. X is the opposite. It's 6.5, which is the length of the hypotenuse, multiplied by the sine of 40. Not just times 40, I need it by the ratio of 40 degrees, so it's the sine of 40. You type that just like that exactly into your calculator. We get an answer, 4.18 centimeters. So this side over here will be 4.18 centimeters long. Let's go on. Here's another example. Now, I've deliberately flipped this triangle around so that you get an understanding of what opposite and adjacent are. This is my angle. Sorry, I brought up some words ahead of when I wanted them. This is my angle right here, 59 degrees. That means that this is the opposite over here because it's opposite the actual angle. So that means this 15 metre line is the adjacent as the arrow is showing you. It came up a bit early, I apologise for that. It's the adjacent because it's making the angle, it's adjacent with it, and of course I think you knew this one, that has to be the hypotenuse. You certainly can't muck that one up. Because I've got adjacent and hypotenuse, this is actually going to be a little bit of a different one. This is a cos problem. Now again, don't worry how I know that, that will be taught to you. Here's your formula, cos of the angle equals adjacent divided by hypotenuse. Let's rearrange it because I want to find the hypotenuse. So let's rearrange it to hypotenuse equals adjacent divided by the cosine of the angle. Bring up the next thing. I have swapped my letters for numbers. Adjacent is 15. I've swapped it for 15. The angle is 59. So the cos of 59. Type that into your calculator. I hope at this stage of your life I don't have to tell you that 15 over the cos of 59 is 15 divided by the cos of 59. Type that into your calculator, bang, there's your answer. That means that this length here would be approximately, or pretty close to, 29.12 metres, depending on how you round. That is pretty much trigonometry in a nutshell, just as an introduction. As I said, you've probably got a million questions going on in your brain about how the hell, what is sine, what is cos, what is tan, how does he come up with these things? It's actually fairly simple and it will be shown to you in class. Now for the benefit of 9 red, you are allowed, you have to do for me 1 hour of homework per week. I'm going to let this go. It's only about 12 minutes long, but I'm going to let this be worth 20 minutes of your homework. So to prove to me that you that you watched this video, could you write this word in your homework book? SOHCAHTOA. It's going to control everything we do for the next 2 weeks. Everything is going to be about SOHCAHTOA. So write that in nice big letters in your book, and that tells me that you did you watched this video, which I'm going to count as 20 minutes of homework. Alright guys, see you in class.